Hey, hope you're doing good this afternoon, this morning, this evening, this year. I don't know when you're watching this, but we're about to math it up. Oh, that just never gets old. All right, so Exponents Assignment 2, and we're going to jump right in and start doing this. So it starts with question 1a, and it is evaluate the expression positive bases. Now, 3 to the power of 2. I think we all hopefully have got this. Running 3 times 3, this is going to be 9. Right? So it's like 3 multiplied by 3, 9. 1b, 5 to the 3rd power. So I'm going to do this over here. 5 times 5 times 5. So this is going to be 25 here. And 25 times 5 more is going to be 125. That's our answer. C, 4 to the power of 4. So 4 times 4 times 4 times 4. And you can go through this. This is going to be 16 times 4. And that's going to be 64 times 4. And 64 times 4, 240. 240 plus 16, 256. 256. 256. All right. Now we're going back over to 1D. Oh my gosh. 5 to the power of 5. So this is 5 times 5 times 5 times 5. And for this one, I'm going to bust out the old calculator once I get rid of that calculator. And I'm going to go and use my calculator. 5 exponent. You see what I highlighted there. And it's to the power of 5. 5 exponent 5 is 3,125. 3,125. And of course, we can always check our answer. 1D. Yeah, there it is. 3,125. 2 to the power of 6. Now, this one's smaller number, so it's not as hard. Let's write this one out. Let's do the math here. So 2, 2, 2, 2, 2, 2. Let's use our dots. Save some scribbling. 4, 8. Short work here. 16. 32. 64. So got a little bit less. It's a much smaller number, even though it's to the power of 6 because the base is 2. It's only 64. Well, 6 to the power of 4. That's going to get pretty big pretty quick again. So I'm just going to let the calculator do the work. As long as you know what you're doing, it's not as important if you do the computations with a calculator. All right, 6 to the power of 4. Well, 6 is our base. Raised to the power of 4, 1,296. 1,296. We'll put a comma there. All right, going on to 2. Now, evaluate the expression with a negative base. So, same idea, but the bases are negative, so we have to pay attention to the positive, negative answer. And the rule generally is if there's an even number exponent, it's going to be even. It's going to be positive, and if there's a negative number exponent, it's going to be negative. So we're going to go, we can model this over to the side, -4 times -4, and you can see negative times negative, positive 16. 2b to the power of 3. So now we have that odd exponent. It's an odd number. So we're going to get a negative answer, and it's going to be negative 27. 3 times 3 is 9, times 3 is 27. That's 29. 27. 2c, 2 to the power of 4. Again, even exponent. 4 is even. Even exponent is going to be a positive answer. So 2 times 2 is 4, times 2 is 8, times 2 is 16, positive 16. Negative number, sorry, negative answer because an odd exponent to the power of 3. So it's going to be negative 125. 5 times 5, 25. Times another 5, 125. Let's do E. This is 2e, negative 5 to the power of 4. So we could show our work here, just so we keep in track. So negative 5 times negative 5 times negative 5 times negative 5. I'm doing this because I just want to make sure I get the right answer. It's here. This is 25 positive times negative 5, which is going to get us to negative 125 multiplied by negative 5. So this is going to be, we have 500, 625, 625, negative times negative, positive 625, 625, and 2e, 625, yeah. It's always nice to check just to make sure you can get them as you go there. Again, 2 to the power of 5. Do we see that somewhere earlier? Negative 2, it's an odd exponent, so we're going to have a negative answer. So we'll put our negative sign. 2 times 2 is 4. 4, 8, 16, 32, 64. Negative 64. I've just doubled it 5 times. All right. 3. What? There's some like dark music here. All right. Now we have a mixture of positive and negative bases and some fractional bases. So we'll get to those right away. Negative 3 to the power of 2. This is going to be positive 9. 3b. Positive 4 to the power of 3 cubed, 4 cubed. This is going to be 64, positive 64, negative 12 squared, so it's times itself. This is going to be 144. So it's a negative times a negative, 144. You got 1/2 cubed. So if we write this out in expanded form here, so it's going to be 1/2 times 1/2. And if you remember your fractional multiplication, this is going to be equal to 1 times 1 is 1, 2 times 2 is 4. Our answer will be 1/4. Simple as that. -3/5. All right, so let's write this out in expanded form. We have some space here. So we have -3/5 times -3/5 times -3/5. Now, 3 times 3 times 3, that's going to give us, well, I guess we could do this strategy and go 3 times 3, so it's going to be 9/25 times -3/5. And when we get those two together, it's going to be 3 and 9. That's going to be -27 over 125. Now, do 27 and 125 have a common number in them? 9. I don't think so. Greatest common factor greater than 1? I don't think they do. I think it's just -27 over 125. So, answer is -27 over 125. Last one. -2/3 to the power of 4. -2/3 to the power of 4. All right. So let's do this. We know it's going to be, because we have our number here, this is a even number, so it's going to be a positive answer, because we know anything to an even exponent is going to be positive if it's a negative base. So 4, 2, 4, 8, 16. 16 over 4 times 3, and then we have 3 squared is 9, times 3 is 27, times 3 is 81. 16 over 81, and common denominator, lowest common multiple, 1. Close. Yeah, 1. That's our answer. Okay, next group. So if you look here, we are representing our fractions as repeated division. So we're expanded form. So a negative fraction is the same, but we represent it as a positive base and division, repeated division. So what I want you to take this and write it out. Don't solve it, just write it out. So 1 is our numerator, and our denominator is going to be 2 times 2. Simple as that. That's your answer. And it's also equivalent to 1 over positive 2 to the power of positive 2, exponent 2. Right, that's the same thing. So I'm just expanding it, really get that point across here. So let's go. This one is going to be equivalent to 1 over 3 times 3 times 3. And these dots can represent multiplication. 6 to the power of 4 is equal to 6 times 6 times 6 times 6 as the denominator. 1 is the numerator. That's all I want you to do. So this is equal to 1 over 4 times 4 times 4. Nice and simple. So we're not solving, we're just writing an equivalent expanded form. 1 over, oh boy, 2, 2, 3, 4, 5, 6. That's a long... Obviously, you wouldn't do this unless it's a worksheet like this. We're like training, we're helping you understand what this was representing. This multiple negative exponent, 1 over, the base is 12, 12 times 12 times 12 times 12. That is going to be a low number. Very low decimal number. Okay, next one. We're collapsing. So we've given the long form, and I want you to shrink it down into a negative exponent. So this is 1 over 2 times 2 times 2 times 2. And this is the exponential form of this statement. 2 to the power of negative 4. So move in the opposite direction. So we have, this will be equivalent to, our base is 3. And we have 3 of them. Negative 3. That's our answer. 3 to the power of negative 3. Not too hard. Our base is 4. So this is equivalent to base 4 to the power of 2, because there's 2 4s and it's negative 2. To me, it's more specific. C. How many other? 1, 2, 3, 4, 5. This is equivalent to base 3 to the negative power of 5. Negative exponent 5. Five to the power of negative 4. E. Base is 6. This is going to be equal to 6 negative 2 to the power of negative 2 to exponent negative 2. We have 1, 2, 3, 4, 5, 6, 5 to the power of negative 6. 5 to the power of negative 6. All right. Not too hard. Now we're going to solve these. So now we're actually just going to skip all of the expansion and just solve them. We're going to, but this one's specifically asking you to solve it as a fraction. And for example, 3 to the power of negative 3 is like the fraction 1 over 27. All right, 2 to the power of negative 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be 1 over 16 as an answer, as a fractional statement. 3 to the, oh, look at that. Look at this right here. Nice little help. This is going to be equal to 1 over 27. 5 to the power of 2, negative 2. This is going to be equal to 1 over 25. 1/25. This is equal to 1 over 3 to the power of 4. 81. 1 over 81. 7 to, oh boy. All right. This is equal to, let's see my mental math here. This is equal to 1. So we go 7 times 7 times 7. That's 49. Times 7. 343. 343. 343. That is 6E. Yeah, got it. All right. 6 to the power of -4. This is equal to 1 over calculator 6 to the power of 4 is equal to 1,296. 1,296. A little bit more than I wanted to mental math there. All right. So the next one is solving the negative exponent, but then you're going to turn that fraction into a decimal. Turn it into a decimal. So this can happen directly on your calculator, or you can use fraction to decimal conversions, which again, I'm going to use a calculator for it. I'm not teaching long division right now in this unit. All right. 6 to the power of -2. This is going to be 1/36th. And that will be equal to, let's see here. 6 to the power of 6 to the power of 2 negative 0.027. 0.027. You can also skip that part and just do the division, like 1 divided by 36 on your calculator, if that's easier. 7 to the power of -3. So this is going to be what? 343, 100 over 343. Remember that from earlier. We can do that. 1 divided by 343 equals 0.029. 0.0029. But you could also round to 3. Okay. Next one. 8 to the power of -2. So this is going to be equal to 1 over 64. 8 times 8. 1 over 64 is going to be equal to, we can do that division. 1 divided by 64, 0.0156. 0.0156. Or you could round up to 0.016. I think it's kind of what I asked to do. Round to the nearest thousandth. 4 to the power of 3. This is going to be also 1 over 64, which is also equal to 0.0156. Same question. 1 over 144. 12 squared is 144. Now to convert that to a decimal, you go 1 divided by 144 equals 0.0069. 0.0069. You could round that to 0.007. Last one. 13 to the power of -2. 13 to the power of -2 is... right, so 13 squared. 130 plus 36, 169. 1 over 169. $13 squared, 169. Okay. 1 divided by 169 equals 0.0059 equal to 0.0059. Awesome. All right, we're coming up to our last question set here. So now this is just a mixture of things we've seen so far, and then we're done. 2 to the power of 6. 2, 4, 6. 2, 4, 8, 16, 32, 64. 64. Doubling it 6 times, starting with 2, counting as 2 to the power 1. And 2 to the power of -3. And I can answer this as a decimal or fraction, but I'm going to leave it fraction. So this is going to be equal to 1 over 8. 4 to the power of -3, that's 64. 16 times 4, 64. 1 over 64. 4/7 to the power of 3. Okay. 4 to the power of 3. 64. 7 to the power of 3. 7 to the power of 3. 49, 343. Common denominator in there. 4 and a 7. 9, 10, 64, 3, 4. I don't think so. 8. D. No. E. Negative. Okay, so it's going to be a negative answer because we have a odd exponent on a negative base. So up top we're going to have 1. On the bottom we're going to have 36. 36 times 6. 36 times 6. 180. 216. 1 over 216. 8e. Yeah, 216. Oh, and our last one, negative 216. And our last question, 8. It's going to be negative answer, and it's going to be 8 to the power of 3, 64 times 8. 64 times 8. 8/11. 8 to the power of 3. 512. Oops. 512 over 11 to the power of 3. 11 cubed. 100. 1,331. 1,331. Common denominator in there. Wow, that's 3, 8. I don't know, what is the... How do we find that? Yeah, that's kind of what I thought. No common denominator that was jumping out at me. That's it. That's the worksheet. 30 minutes. If you have questions, ask your teacher. If I made a mistake, tag it. Say it's wrong, Pearce. Either way, keep doing the math.